a good student, aren't you? Yeah, look at that now, look at that. I've never seen anything like that before. It's amazing. Can you open up the questions? We didn't do the homework on work.
Oh, I know, but like they're in the same.
Pressure was included in work, yeah. There wasn't a homework for the conservation of energy, and we have to continue the kinetic and potential. So,
Mine?
oh, this is mine.
No.
This is mine.
Andere.
This is yours, I suppose. Look, I've already damaged it.
Thank you.
No problem. Right, where did I put my pen? No, not this one. You know which one I need. Special pen. Right, have you got the questions? What's the first one there? So who's going to Galway then? Good. No, Galway? Huh? Are you going to Galway?
I don't know.
Okay.
Is it?
It's good to go.
Do you have any Hamasi there?
Yeah. They would.
Is it lit?
Huh?
Is it lit?
Lit? Is there lights?
No.
Is it lit?
Yeah. That's a slang term used for describing a poetic place or an exciting place.
I've never heard this term before.
It's an American. It's an American.
Yeah, okay. Is it lit? Yes. Alright, what's the first question?
A woman pushes 20 kg of coal by her foot along the ground
Yeah, okay. Yeah.
of a distance 4 meters by applying a force of 200 newtons horizontally. How much work has she done to the coal?
And what's the distance?
4 meters.
4 meters. So the work is 800 joules.
Huh?
Yeah.
Is there more to it or just that?
There's if her foot is roughly 15 by 5.
What's the pressure?
What's the pressure on her foot?
Sorry, the force. What was the area? 15 by.
It's centimeters too.
Yeah. 15 by.
5.
15 by 5. So like this.
No. Yes.
So it's 200 divided by 15 by 5 centimeters. So that is a pressure of 26.7 kilonewtons.
I agree.
Good. Who's that now?
No, that's
Oh yeah. Okay. Next now. What happened to you? Alright, okay. Yeah, you might need to move that table. Who put the table there like that? Come on. What's number 2 now?
a man left 20 kg of coal vertically up 1.5 meters to his shoulder at a constant speed. How much work has he done?
What's the distance? 1.5?
1.5 meters.
So to lift this, how much force does he need?
20 G.
20 G. So the work, roughly. The work is the force by the distance, which is 20 G by 1.5, which is 30 G, which is what's like 297? 294.32 joules. Okay, what else is there? Next question or?
No. If his hands are roughly circles of radius 4 centimeters, what is the pressure on them?
4 centimeters? Radius. So it's 2 hands, and it's like this. Yeah. Two hands.
Yeah.
He lifts the coal with. No, never mind.
Can we do a 2P equals 2?
Yeah, you could. Yeah. So what answer did you get here?
I got 19. Oh. 19,509.7.
Did you get that as well? Should I check it?
Not sure.
294.3 over 2 pi or squared.
Oh. And then divide by square.
No, I have the 2 in there already.
Oh.
Yeah.
Why did you use the word not force?
Did I put in the wrong force? Oh, thank you. Thank you. That should have been 20G. Yeah.
Yes.
196, thank you. So, I'll just write it in here, 20G. Right, that's what you said, 19,500. So we'll say 19.5 kilopascals. Okay,
What if I got 19.509?
that's fine for the exam. I need it to be right by this much at least. Yes? What's wrong with wrong?
Why 2p?
2 hands. Right, 3.
A voice starts to put in.
Oh yeah.
Just if you could go back to it. In the question it says his hands are roughly circles of radius 4 centimeters.
Yeah.
Means each hand is
Yeah.
4 centimeters?
Yeah.
So doesn't that mean, because the formula to calculate the radius is pi r squared,
Yeah.
shouldn't we multiply that by 2?
Yeah, that is our.
By r squared.
But then if you divide it by 2, because what I'm guessing is when I multiply it by 2 I get around 8,000.
When you multiply what by 2?
The final answer.
No.
So you're doing the 2 twice. I just put the 2 in straight away with the area. What you did was you left the 2 out,
2p, yeah.
and what you're doing is you're leaving the 2 to the end. That's all fine, but you have to do only one of them. You can't do more than one of them. So you put the 2 in at the start, I put the 2 in the middle, and if you want you can put the 2 in at the end. So if you leave out this 2, then at the end you should divide it by 2. So you're dividing by 2 at the end, so then you should leave the 2 out from here. Yeah, and you are leaving the 2 in at the start.
Yeah.
So
divide it.
yeah. So I mean that's fine. You just have to do one of them. That's all. Okay. Number 3 now.
A voice starts to put a torque of mass 10 kg over a smooth surface by means of a rope that makes an angle of 45 degrees with a horizontal. He puts it a distance of 2 meters. The tension of the rope is 98.1. How much work has the boy done to the car?
So you only care about which? The horizontal or the vertical?
Horizontal.
The horizontal, which is 98.1 cos 45. So the work done to the car is 10, it is not, it is 98.1 cos 45 times 2. 98.1 times 138.7 joules. Right, what's next?
A
Last
plane.
one.
Number 4?
Yeah, a plane
Yes, the plane.
takes off at an angle of 45 degrees
Okay.
with the horizontal.
Let me just draw that. Yes.
The plane is vertically accelerating at 3 meters per second squared, and the mass of the plane is 80,000 kg. How much work have the engines done during the first 1 minute of the flight? Do we have to combine the work of both the engines, or do we have to divide it to find engines? I think it's combined.
You also have the time.
Yeah, we
The
have
time.
60
Mm.
seconds.
What was the answer to the previous question?
138.7. So what's happening? Yeah.
SUT.
Yeah, there's a few things going on. You also have the time as well, don't you? What's the time here?
60 seconds.
60 seconds. So, I think a UVATS will be good to work out the height of the plane. So if we just look at the vertical, it's only, no, I didn't tell you this in the question, but it's only accelerating vertically. It's moving at a constant speed horizontally. UVATS 0, don't know, 360, don't know.
So it's like a projectile.
It's like a projectile except instead of accelerating down, it's accelerating up. Key difference for planes.
Y is using.
Oh,
It's taking off.
yeah, but
I mean, like it's moving.
yeah, but before it was moving, it was at rest. You don't jump into a moving plane, I hope.
No, but
Yeah. So when you got into the plane, it was at rest and it began to move. Right or no?
yeah.
Yeah. S equals UT plus a half a T squared. What's that? 3 times 1800.
5,400.
5,400 meters.
Can't we use an SMA?
Yeah. So, work is force by distance. Yes. Now,
F equal MA.
yes, and F equals ma.
So calculate the F.
Nearly. If you look at the plane, there's a force in the engine. True.
Yeah.
Right now, we just really care about this force, because this is the one that's raising it in the direction we're interested in. There's not. Okay, there's going to be some force here, but we just care about this one right now. Now, I tell you it accelerates up with 3 meters per second squared. But there's also a weight here of 80,000 G. So the F that equals ma, that's equal to 80,000 times 3. That F is not the F of the engine. It's the total force. Let me call the engine's force Fe. So what would that F be? It would be Fe minus the weight. So the Fe is 80,000 times 3 plus the weight. And this is maybe what people forgot. Is that what people forgot? Yeah. So 80,000 times 9.81 plus 80,000 times 3. I got this big number, 1024800.
Sorry?
Yeah. Yes?
Why we not calculate like FE is the sin FE sin 45 equal.
Yeah, you could say this is F and this one is cos and this one is sine.
Yeah.
So you would get
F sin
F
45
sine 45 minus W.
minus W.
Yeah. Oh, sorry. Oh, sine. You're asking about this one.
No, sine is up.
No,
Sine.
sorry.
Yeah.
Yeah. Well, still minus W.
Why?
This F is not this F. This F is the total force vertical. I need to give it a different letter. V.
Yeah, but I mean, why not F sine 45 equal 80,000 G?
No, it doesn't, because it's accelerating. So the force going up is bigger than the force going down. No, I know what you're saying. You're saying why not F sine 45 equals W? That's because it's not balanced. It's accelerating up. Yeah. Okay, that's the force, and we know the distance. We got it earlier. What was it? 5,400. So if you multiply it, 5,400, isn't it?
Yeah.
What's 5,400?
The distance, wasn't it?
55,
Yeah.
5392.
Earlier here, Andrew.
Oh, yeah,
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 yeah.
Yeah, so what did you get for the work then?
553392.
5.5 times 10 to the
Four
power
zeros.
of
5.9
5
Yeah.
times 10 to the power of 9.
joules then. Yeah.
He was giving you this one.
Yes, it sounded like that. Call me on 55339210. Okay. That was a very hard one, wasn't it?
So,
I still didn't understand.
That's okay. I don't expect you to, because it's hard.
But what about the 45, right? Like 45.
The 45 was something I didn't need to know. Now, if you wanted to, because you know the app, here it is here. If you wanted to, you could then say, what is this? 1024800. This one would be 1024800 over root 2. And this one here will be, oh no, sorry, no, that's wrong. You've worked out this is 1024800. Because this is 45, what would this be? Yeah, what number would be the answer?
This number over the root.
No. It'd be the same. Why? 45. But I didn't care about this. Why don't I care about this?
So why you put it?
because it's more done.
Because I'm trying to teach you that sometimes you don't need everything in the question. Because in the very first question I gave you the mass of the potatoes, or whatever it was she was pushing. Did you need to know that? Charcoal, whatever. You didn't need to know that. So I'm putting some information in the question that you don't need.
Makes it harder.
Exactly. That's my point. I never said I would make it easy for you.
Can I see?
Yes. Back here?
Is there a reason that we put it in power form, or is it?
No, just
So we
be a
put
bit
it-
neater.
put it
Yeah.
Kilo, it's 9.
9, 10 to the 9, 10 to the 6 is mega, 10 to the 9 is giga. So it'd be 5.5 gigajoules.
Start memorizing them. 10 to the power.
You'll need to memorize those prefixes.
Sometime later in your life.
No, the sooner the better. What are you studying next year? Yeah, okay, yeah, the sooner the better. You can memorize those prefixes.
I
Okay.
think to memorize them for this year. So,
No, you do. Because if in the exam the question said 5.5 gigajoules, how are you typing gigajoules on your calculator?
I can
Ask who? I'm not going to tell you.
You can tap giga.
Huh?
You can tap giga.
On that one? Well, then maybe
Yeah.
you can on the other one.
Could you tell me how?
Later.
I thought it is the booklet.
No, it's on the booklet.
That's giga micro.
Oh, I don't think calculator covers are allowed then, are they?
They are.
Oh, okay.
Nothing in it. That's why I threw my cover away.
Really?
Yeah, we were not allowed to get the cover
Calculator.
inside the exam.
Yeah.
That's why so many of my students don't have calculator covers.
Yeah.
Well,
That's new, so.
you still hold on to that
Are you
cover.
sure we're allowed to get them inside the exam hall?
Well, if you're not, I've been doing it wrong for the last 9 years.
Yes.